Find the center and radius of each circle and any intercepts. So we have here a circle that's in general form, not standard form. And it's hard to see the center and the radius in this format, so we're going to want to write this into standard form. So in order to do that, we basically need to group the x terms together. So we'll have x squared minus 4x, leave a little space. Then we'll have positive y squared minus 2y, leave a little space. And then we're going to move this constant over to the other side, making it positive as it crosses that little equal sign. So negative 15 will become positive 15 on the other side. Now from here, we need to basically complete the square on these different pieces. Okay, so let's start with this piece here. We need to take half of the middle term, so minus 4 divided by 2, and then we're going to square that. So we'll end up having negative 2, right? Because 2 goes into negative 4, negative 2 times. Then we'll square that and we'll get 4. Now, that means that we'll add 4 to this piece of the equation. If we do that there, we have to do it on the other side as well, or else we'll have an unbalanced equation. So what we just did is we created a perfect square trinomial here that involves this x variable. All right, let's do the same for the y now. We'll take half of that middle term, so negative 2 divided by 2, and we'll square it. Well, half of negative 2 is negative 1. And if we square that, of course, we get positive 1. So if I add 1 here, I have to add 1 to the other side, again, to maintain the balance in the equation. All right, so we can factor this trinomial now. Let's split it up into 2 parentheses. It'll be x and x. Because of the positive sign, it means we'll have 2 of whatever sign is on the left there. That'll be 2 negatives. And we need factors of 4 that add to give you 4. Well, that'll be 2 and 2. And so the factoring here is just x minus 2 squared. Let's factor this trinomial as well. It'll be factored as a parenthesis times a parenthesis. Of course, we'll have y and y. The fact that it's positive on the right means it'll be 2 of whatever sign is on the left. That's 2 negatives. And the factors of 1 that add to give you 2, of course, that's 1 and 1. So it'll end up giving us plus y minus 1 squared. And all of that will be equal to simply 20 on the other side, right? Okay, from here, you now have the equation in standard form. Now that 20, I'm going to write it a little bit differently here. I'm going to say that it's basically what? The square root of 20 quantities squared. This way I have it as something squared, right? If you square root 20 and then you square that, you end up just getting 20 back out of it. So by putting it as a square root of something squared, I now have it written in the r squared form, right? Okay, so you can identify the center now. The center is simply h comma k, right? And the h here is 2, and the k is 1. Remember, we take the opposite sign of what we see in the parenthesis, right? All right, and then finally the radius, of course, is just the square root of 20. So if you want to test this equation for intercepts, you'll see that the general form is actually pretty easy for that. So the way you would test it for intercepts is to plug 0 in for x, right? And that will give you your y-intercept. So let's see if we have any of those. If x is 0, it means that all the terms with x will cancel out of the equation. You'll just end up with y squared minus 2y minus 15 is equal to 0. And then, of course, you'd want to see if there are any such factors, right? So are there factors of 15 that subtract to give you 2? Well, 5 times 3 do, right? So in other words, we'll be able to say y, and we'll probably say negative 5 and positive 3 is equal to 0. So negative 5 times 3 does indeed give you negative 15, and when you add them, it does indeed give you negative 2. So it is the proper factoring. That means our solution for this will be y is equal to 5 and y is equal to negative 3. So we have two answers here, positive 5 and 0 and negative 3. We can do the same thing again, but this time setting y equal to 0, and that means all the y terms would cancel out of the equation. So if that's the case, we'll end up having x squared minus 4x minus 15 is equal to 0. And again, we'd see if it factors. Are there any factors of 15 that subtract to give you 4? I don't think so, right? No factors of 15 subtract to give you 4. And let's check that discriminant to see if there are any real solutions to the quadratic formula. So remember, the discriminant is basically the b squared minus 4ac piece, right? So in this case, that would be the square root of b squared would be negative 4 squared, or positive 16, then minus 4 times a, which would be 1, times the c term, which is negative 15. All right, so that will be a positive number. That'll basically give you what? The square root of 4 times 15 is 60, and 60 plus 16 is 76. So the square root of 76 would basically be our discriminant. Okay. All right, so the square root of 76 would be that radical part of the quadratic formula. All right, so it doesn't look like it factors. Let's go ahead and try to use the quadratic formula on it. It'll be x is equal to negative b, which would be positive 4, plus or minus the square root of b squared, which would be 16, minus 4 times a times c. And all of that would be over 2 times a, or just 2. From there, of course, you'd get 4 plus or minus the square root of, so 16 minus 4 times negative 15 times 1 is basically 76 if you work that out, and that'll all be divided by 2. All right, so 76 is 4 times 19, so we can say 4 plus or minus the square root of 4 times 19, all divided by 2. And then finally, the last step of this is to say the 4 can come out here as a 2, and that'll give you 4 plus or minus 2 square roots of 19 over 2. Then the 2 can cancel out with these guys, so you'll end up having 2 plus or minus the square root of 19. So those are our x-intercepts, 2 plus or minus the square root of 19, comma 0. All right, so those are your intercepts. You have your center, you have your radius, and that's the solution for example A. Let's do example B then. All right, for example B, we have a little simpler equation, but sometimes simpler equations can actually be harder to work with. All right, so let's start by trying to write it into standard form. So we'll group the x's together first. So x squared minus x. Give a little space there, then plus y squared equals to 0. So if we want to complete the square on this part, we just take half of the middle term, which is negative 1, and we square that, giving you positive 1/4. Now we'll add 1/4 here, and also to the other side of the equation. Now for the y part, we don't have to do anything because we can say that that's just y minus 0 squared, and that will tell us the y coordinate of our center. So when I rewrite this, I can just say, okay, let's factor this trinomial. So it'll be x and x. The positive sign means it'll be 2 negative signs. And then the factors of 1/4 that add to give you 1 are basically 1/2 and 1/2, right? Because 1/2 times 1/2 is 1/4, and if you add 1/2 to 1/2, you do get 1. Okay, and then we'll have plus y squared, which I'm going to write as y minus 0 squared. That's the same as y squared. And on the other side, we'll just have 1/4. All right, continue the rewriting. We'll end up having x minus 1/2, quantity squared, plus y minus 0, quantity squared, is equal to, I'm going to write this as the square root of 1/4 quantity squared, right? All right, that means the center of this circle is basically the 1/2, comma 0, right? And the radius is equal to the square root of 1/4. But that's the same as the square root of 1 over the square root of 4, or in other words, just 1/2. So r is 1/2 and the center is 1/2, comma 0. Now as far as getting the intercepts, let's go back to the original general form of the circle they gave us in B, and let's go ahead and plug x and y in as 0 separately to see what the intercepts are. So let's start with the y-intercepts. If I let x be 0, I end up having y squared is equal to 0 as my equation. So in other words, y is equal to 0. So that's our y-intercept. It's 0 basically, or in other words, the origin. So that means if I plug 0 in for y, I'm going to get the same answer. All right, let's test that. If I enter 0 in for y, I'll end up having x squared minus x is equal to 0, which means that x times x minus 1, right, if I factor out the common x here between these two terms, that's equal to 0, and then we set them separately equal to 0, we get x is equal to 0, but I also get x minus 1 is equal to 0. So putting that together, that'll end up telling me that x is equal to 1 or that x is equal to 0. So we end up having 2 x-intercepts. Okay, and that's it. Your center for example B. is 1/2 comma 0, your radius is 1/2, and your intercepts are given in this table here.